Hello YouTube, it's me again after a while. But I had been very busy doing things like repairings of musical equipment and some hi-fi stuff and so. But since 2 weeks I've been back in electronics, and this is another attempt of doing a phaser. I've done some others over the years, solid states and with tubes as well, and all had been this as the to change the filters, the cutoff frequencies, or the frequency change done by these ones. This is a light dependent resistor and the LED together with this shrink wrap around to darken it. And I came across some infinite turn capacitors like these ones here. They all need some attention because they got ball bearings inside, and I need to do a little bit work on this one. And I got another one as well to build up another string of two of these capacitors, and with the stepper motor in the middle to drive in. Set the whole thing up and feed it with a white noise signal from my little MP3 player. That's what you see over there with a little hum. Maybe the lights over there produce a little hum with because this is very high impedance stuff here. It's about 20 mega ohms input impedance, because I got around 180 puff per condenser capacitor over here, and therefore I need a very high impedance to have a phase changing effect in within the audio spectrum. Okay, nevertheless, of this anyway, just check how is it. I got a little amplifier over here. Just switch it on. Here we go. I will check the video later if it's clearly audible what I'm doing here. So put this a little bit down. I changed the frequency of the notch by turning the capacitors. So therefore it catches a lot of noise and hum, but I managed to tweak it down. Over 80%, because when I tested the thing for the first time, it just hummed, was very noisy, and therefore I need to do a lot of work with it. Anyway, I changed the center frequency of the notch via turning this caps rotor. This is the minimum capacity, this is the maximum, and I have set my DSO to fast Fourier transformation, and you can see on the screen, this is the notch here moving around. I set it up to 625 hertz per division. You see this here goes this is maximum here. 1, 2, 3, 4, 5, 6, around 6.5. I need a calculator for this. Oh, over here. Okay. So just run the numbers here. 1, 2, 3, 4, 5, 6, 6.5, 6.5 multiplied by 625 around see this here, around 4K is the maximum, and the minimum is around 600 hertz or something like. So, but this is just halfway through, because the other you need to spin this, otherwise it won't make any sense here to incorporate the stepper motor. Therefore I got the little Arduino here, plug it in, a little hum because of this cable go away when I power the motor. Here we go. You see the spinning and moving. You see it? Yeah, you see it on camera. Yeah, good. Give it a little more to have a clear view and switch it off. Here we go. Okay, so I also added the feedback. You see with the feedback I also can narrow the notch. And now it goes to put this into dB lock mode. Let's see where it is. Don't know. Oh, way off. There we go. The scale is better, I think, for this one. I need to it's a little bit different when switched into dB logarithmic scale. And here we go. You can tweak it maybe to maximum notch and so on. I think it doesn't get any better with the feedback. Take it down a little. Looking for the maximum notch again. Over here, yeah. this. Turn it down a little. I still got some work to do because I just it's spinning, and I added a little vibrato, and this is just doing with random numbers. Slow it down, speed it up, and the depth of the vibrato is randomized as well. And the goal is to control the whole thing via the MIDI protocol with controllers and stuff like this. Maybe add a synchronization to the MIDI clock. I tried it, it works, but I need to do a lot of coding. But for this demonstration, random numbers should be working fine. I also tried it with various audio signals, music and stuff like this. But I just have a little tune done by myself. Just do it again with the white noise. Because with lots of high frequencies within the signal, one can hear the phasing effect best, I think. Anyway, this one is starting to work as I wanted to, so it was about time to do this little video. I hope you have found it a little interesting. And I think that's it for now, so just need to thank you for your time to watch it, and see you on the next. Thanks and bye bye YouTube.